So hello everyone, and today we'll be seeing one of the problem from Leetcode. It says count mentions per user. So we are given an integer of user nums representing the total number of users and an array events of size n cross 3. Okay, so number and an array of n cross 3 size. Each event can be either of two types. So there are two types of events. One is messaging event and one is offline event. Messaging event is something like this event contains a set of users which was mentioned users was mentioned in the message at a timestamp ti timestamp of I. So one position contains timestamp of I guess index 1 is common within both of them. So the mention strings, so there is second index 2, which has mention strings, and index 0 is the identifier message or offline. Make sense? Mention string has three types. It says one is either id number, where a number is an integer from range 0 to number of user minus 1. It is a valid index. There can be multiple IDs separated by a single white space or may contain duplicate. Example makes this clear, something like this: a white space separated list of IDs where ID is mentioned at ID and the number. The number is a valid index. Makes sense. There can also be another mention strings which mentions all. That means I need to mention everyone. And there is here which mentions all the online users. There is an offline event as well, which mentions that which indicates that the user ID has become offline at timestamp ti for 60 time units. So timestamp means that it has went offline for 60 time units. Then the user will automatically be online again at timestamp I plus 60. Makes sense. So, and what we wanted to do, we wanted to return an array mentions where mentions of I represents the number of mentions the user with id I has across all the message events. So all users are initially online, and if a user goes offline or comes back online, their status changes is processed before handling any of the message. So the transitions occur first and then the message handling takes place. Makes sense? And there is also note that a user can be mentioned multiple times in a single message event, and each mention should be counted separately. So if I counted here id1 space id0 space id1, then id1 should be counted twice. Let's see an example. Example makes it much more clear that we have three events. First one is a message event, and as we have told that every user is online initially, we see that at timestamp 10 we got an mention of id1 and id0. So initially, if I had a mention, we got it 1 1 because both IDs are counted or mentioned at least once. Then we see a user goes offline and id0 goes offline. Then there is an event at timestamp 71. But guess what? Before processing of this message, we make a transition and the user with id0 comes back online and he reads the mention. And he is mentioned again, and that's where he is mentioned. That is the reason the count is 2 2. A very similar case, but in this case we have mention all, and everyone is mentioned irrespective of anyone is online offline. And there is example 3 where we have offline event initially and user 0 id 0 goes offline, and then we see that hey, there's a message for online users, but guess what, id 0 is offline, so no mention for them and the rest of folks who are online. Cool. These are some constraints. Constraints are not much, there are only 100 when it comes to length of event and number of users. So cool. I'll just make it short, and before proceeding we can discuss few things. So the entire problem here revolves with here. If we have a message type and it is here, then we need to do compare best operation. Exactly. Else for all we have all, no compare, and for id, whatever IDs we are getting, no compare. So in these cases we don't compare, but only in the case of here we wanted to compare. Now there's also of offline event, and it says us to make transition offline online transition first and then go for messages. Makes sense? And it says it has id, so current time plus 60 is offline. So this much data we have right now, and with the help of this data you can clearly spot that we need to do something for event 4, line number 4, that is messages, which will have here, or messages which will mention only online users. So what can we do? The first and foremost thing is we need to ensure that the events are coming in the proper order. So events should be in proper order. But wait a second, what proper order means? A proper order means that a timestamp t1 should come, and then it should come timestamp t2, t1, t2, t3, and so on, where t1 is lesser than t2, lesser than t3. That means it should be in a sequential order. It should not be something like, hey, it should not be something like I'm having timestamp 1 as event at 100, but timestamp 2 I'm getting at event at 10, and then I'm getting event at 50. No, that should not happen. It should be sequentially 10, then 50, then 100. Okay, although this is not necessary, but this will make much of our life easier. So I'll just add a note, not necessary but good to have. It will make our life easier, and I'll tell you in the end how can you avoid this and still solve this problem. So stay tuned. And next thing is consider offlines first and have mechanism to understand online users quickly. So there are these things. So how can we do this? Well, we wanted to understand online users quickly. We can do one quick thing over there, that we can have a map or have a understanding where we can get to know whether this person is online or offline. But before going with that, let's start how a person goes offline. So person goes offline upon getting offline event, and stays offline till plus 60. And let's take it minutes for now. Obviously no one stays offline for an hour, and no one wants to be. It should be seconds or whatever. So it stays offline for 60 minutes. So whatever time I have right now, t0, the next online coming time is 60 plus with that. So can I have a array which says next offline, next online, I'll say, on of which it will have an ID, and it will say at what time the next person is offline. That means t0 plus 60, right? And the moment, and at any point of time, if you give me timestamp, I'll tell you if the user is online or offline. How can I tell you that? I'll see that next online is, let's say for t0, next t0 is 0, next online is 60, and if you give me current timestamp is let's say 70, so I'll come to know that hey, 70 is beyond 60, and that means it's online. Else if you give me current is equal to 20, which says that 20 is lesser than 60, that means user is yet to come online and hence it's offline. Cool. This solves a huge problem, and now our entire problem has been broken down into only two chunks. One is to have, okay, let me zoom out a bit. Okay, one is to have an ordered way of timestamp ordering, and next is offline or event management. So cool. Our problem has been simple, so in a very good way. We'll have a result array, we'll have it of size n, and that would be our return result. Let's focus on first thing. How would we order the timestamp? We would take the events, we would sort it based on two things, that I'll get E1 and E2, and once I get an E1 and E2, what I'll do is I'll compare if E1 dot get, I'll get the offline events and on timestamps first. Okay, why it is not zooming out? Okay, I guess of 2 gives us, event of 1 gives us the timestamp. If these are equal, E2 or I'll just take timestamps only. In T1 is E1 dot get 1, and this is an integer. I will get integer dot %. Similar goes with T2, but only the difference here is it is 2 with index 1 only. No, index is still 2. Okay, what's wrong? I'll refresh it. Sorry for a while. Guess it's not responsive. Oh my god. Oh yeah, correct. Oh my bad. Yes, the page was not responsive for quite a while. So far so good. Okay, now once I have T1 and T2, I'll compare T1. If it is equal to T2, I'll consider the online or offline events first, and if these are equal, how can I get online or offline events? So if E1 dot get. How can I get online and offline? By the index, and the index says me that hey, zeroth index gives me the status or the type. What would be the best thing in my opinion is to get a status or type which is 0, and if I'll get a type which is equals to offline, I want this event first, priority, return -1, else I can return 1. Now if t1 is not equal to t2, then I can just return integer dot compare t1 t2. That's it. Now we are assured that hey, at this point we are getting these events are in a sorted manner. Now what I'll do is for each event, I'll take it as where event from events. I'll take one by one event and I'll understand that hey, if event dot get type, if the type equals offline, I need to mark it as offline. But wait a second, I didn't have any map. I didn't have any array for that matter. So next online is new int of n. We also have all is equal to 0. This would be required for later parts for a smart hack. So next online of id is equal to current time. Wait a second, everything would be clear, plus 60, whereas this id is nothing but event dot get 2, because 2 gives us id, and current time would be event dot get, oh I guess 1, yeah, 1 is the current time, right? Let me reconfirm. Yes, 1 is the current time, timestamp. Since this is an integer and I wanted to get it as in %. I want an integer, so that's the reason where id, I took an id and that too should be an integer. Integer.parse int. Multiple parsing, I think the best thing we could have done is to convert these events into a user defined class, and that would be so neat and clean for an interview ready solution. But this is also valid. Ultimately we wanted to continue from here, we don't want it to go beyond at this point once we have an offline event. But once we are at this position, we handle messages. See, if I'm getting this event and I'm taking this event as it is for all, like this is a message event for sure, the type is message, but it mentions all user. So if it mentions all user, which I can get it by 2 equals all, then what I'll do is I'll just make all plus plus. Oh, not return, continue, because I don't want it to go ahead and increment one by one each. I'll do at the end increment all. I'll tell a footnote here for myself to increment all. If it is not all, it can be here. That means I need to check event.get 2 dot here, and if it is that the case, then I'm going ahead to check every ID which is online. ID is less than n ID plus plus. And I'll check if is online ID or next online ID along with current timestamp. Okay, it's getting ugly due to indentations and all. Then what I'll do is I'll just result of the ID plus plus, because it has been mentioned, so I'm mentioning it, and I wanted to continue from here. No need to go beyond, because beyond I'm handling individual. So for where s, and this s is nothing but a string where we get from 2 dot split with spaces. Why split with spaces? Because it is space separated and still we have ID in place, and I don't want that anymore. So I want a ID of category int, of type int, sorry, and I wanted to parse int from s dot substring. I'm taking the substring to remove this ID and just take the numbers. The example makes it more clear. I'm having ID and a number. I don't want I and D as a character. So what I'm doing is I am taking a substring from 2 to the end of string. So once I have that, I have an ID, and if I have an ID, I'll just result dot ID plus plus. So far so good. Nice. And ultimately it says I wanted to increment all, so let's do it right now. For int I is equal to, or int ID is equal to 0, ID is less than n ID plus plus, and I'll just do result ID plus plus, or I'll do plus is equal to a all. Nice. Okay, good. I guess is online we haven't handled. I'll just add a note here. Is online means next online. Is online means the one which we have discussed earlier. Next online should be lesser than our current timestamp, or in short, current timestamp should be greater. I'll add this where current was this, and I'll say current should be greater, current time should be greater than next online of that particular ID. So that this was the condition we have discussed, and if that is the case, I wanted to copy paste the same thing here, and mind that this would give us that hey, this person is online. Good. Let's compile this for any compiler errors. Okay, there are few. Okay, like this here, it needs equals. On line number 77, I didn't provide it equals. Let's compile this. Number format exception. I guess I have missed the index somewhere. This is on line number 67. Let's check line number 67. The ID which gave us 2. Okay, it was not line number 67, it was line number this. Okay, I guess it should be 1. Yeah, the index, I thought so, the index issues. Because this was the error where we wanted to get a time and time is at index 1. There's one error, I guess it would be a minor error. Oh, okay, cool. I need to process time fast, and this was the note here. Make online and offline transactions first and then go for message. And if I'm making online and offline transactions first, I need to have current timestamp greater than or equal to next online. And if that is the case, then only I'm doing this. So it is accepted with sample test cases. Let's check for the rest of test cases as well. So yeah, it has been submitted. It was a very good problem when it comes to scheduling, but wait a second, I would also tell you that it has a bottleneck. It has a bottleneck of sorting. Can we optimize this? Obviously yes, we can optimize this. So can we avoid sorting? Why did we do sorting? We did sorting to understand that, hey, at what moment someone comes online and someone goes offline. So can we avoid that? Obviously yes. Instead of this array, which tells us next online, we can have a ID specific array, or we can have a two-dimensional array. A two-dimensional array would look something like, I'll leave this to you to figure it out and have your implementation, and that would be a good exercise. A two-dimensional array would give us that ID to list of offlines. So it will give you a list of offlines at the moment, at what moment or what timestamp this ID is going to be offline. And when the moment you start passing the timestamps, or the moment you start going through events, you just wanted to do now message events, because you have already did it for offline events. For messaging events, what you will going to do is go check up for all, you got it clear, no issue. For individual, you got it clear, no issue. But for here, there was an issue where you wanted to check whether my candidate is offline or online. Here, you just need to check for this particular ID whether I am offline or online. How would you check? You have already ID and list of offlines. Now, the interesting fact about this is you can have this in a sorted order, checking whether this timestamp consists within list of offline ID, timestamp in offline IDs is merely a login operation, because you'll apply a binary search over there from checking. And with this in mind, you'll come to know that, hey, if the current timestamp minus 60 till current timestamp, if this interval is present within my list of timestamp, list of offlines, then maybe I'm offline. Again, current time minus 60 is excluded, current timestamp included. That is the case here. You don't need to search each and every 60 timestamps, but you just wanted to search these two things. Either this exists, then it's good, check for this, and this timestamps should be adjacent. If not, there are multiple timestamps and you need to consider that, but if it is multiple timestamps, you are certainly offline. Again, I'm decoding too much logic, or I'm overloading you with information. It's up to you to implement, and if you wanted the solution of this as well, let me know. I'm happy to do this, and as usual, I'll see you in the next one.